At this point, your project should look something like this. So you should have the van CMA layer. You can remove the DA layer. We're not going to work with that anymore. You should have this classified NDVI image. Again, your name might look a little bit different. That's not super important, but you should have this classified NDVI image with water/urban, medium density, and then green veg. And then you should also have your projected raster layer along with that. So given that, we're going to go through two different approaches for how we could overlay this vector layer, right? Points, lines, and or polygons is vector data. This specifically is polygons. And this vector layer has a whole bunch of different attributes associated with it. So we're going to go over two approaches to overlay that with this NDVI data, either the raw data or this classified scheme. So the first approach that we're going to walk through is going to use something called the Zonal Statistics tool. So I'm going to show you that now, and then in a separate video, I will show you the other one. So what Zonal Statistics is going to do is it's basically just going to stamp this layer, the van CMA, over top of this layer, and we can use it to calculate the average NDVI value per census tract, the median, the maximum, the minimum, the range, etc. A whole wide range of things. So we're going to do search for zonal statistics. And specifically, you want zonal statistics as a table, right? So a couple options, make sure you choose zonal statistics as a table. And so for the input raster or zone featured data, you're going to use the van CMA. And then you want to make sure that CTUID is for the zone field, and for the input raster, again, you want to make sure you're using the van greenest, the projected raster, not the classified raster, right? So you want the one with the raw NDVI values. Because what we're most interested in here is figuring out what the mean NDVI value is. So under the statistics type, you see that it lists all. It gives you a whole bunch of different options. We can do it. We might as well get it, right? But the one we're most interested in is this one. But this shows you all the different ones that it will calculate if you leave it set to all. So you can click run. And you're going to get this table here. You're going to open the attribute table, and you'll see that it's going to have some information for us. It's going to have this CTUID, right, which is the census tract unit identifier, this thing here. Each census tract has its own CTUID, right? This one here is 93 blah, 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 right? And that would correspond to whatever that one is in here. So what we're going to do, right, because this is just a table, it does not have any spatial data associated with it. This is both spatial data and a table, but it doesn't have the NDVI values, right? So we're going to do something called a join, right? A join is a way to stitch basically a table or append a table, different columns from a table, onto the end of another table. So if you right click and you go to joins and relates, you can click add join. And I just noticed one key point. Before you do this, right, note how I've got this layer selected. Whenever you've got something selected, if you do a process on it, it's only going to apply to the selection. I'm going to hit this clear selection button. It's always important to double check, right? And so the input table is going to be van CMA CT 2016 join field CTUID. The join table just comes up already because there's only one other table in here that we could join. If there were more, we need to be more diligent about it. But it's going to go zonal statistics and then CTUID. And then we will keep all target features. Click OK. Let us do its thing. And now you scroll to the end of the attribute table here. My stupid zoom bar out of the way. You move to the end of this attribute table, and you'll notice that all the values here corresponds to the values here, right? So it literally just took this and it said, okay, where's 9330187.11? And said, oh, that row is, or that record is here. Let's take all of these values and smack them on the end, right? So now we know the mean NDVI value per census tract. We also know the range, the max, the min, the standard deviation, all that information, right? So there's lots of important stuff here. So it's always important to inspect the join. If for whatever reason you have a join and it didn't work, or you want to get rid of it, you can go to joins and relates and you can just remove a join, remove all joins, etc. Or if it didn't work and you need to try again, you can click add. And so once you've got this mean NDVI value here, right, maybe it would help to rename it. So you could go to fields, and if you want to rename something, you scroll down, you got all these joins, and it doesn't let you change the actual field name because it's rooted in this table, but you can change the alias. And so you could say mean NDVI. And that just gives you a bit more of an idea of what you're actually looking at. And then you can save that to apply. So now, if you want, you could change the symbology so you can get a look at what it actually did, right? So if you go to symbology here, go to categorized or graduated colors, sorry. And then you click mean NDVI. You can just leave it at natural breaks, but let's change it to green because we're looking at plant cover. Right, and this is roughly speaking what we might expect. You know, you got these big forested areas up here, and then the dense urban areas and industrial areas around here, right? So kind of just always a good idea, best practice to like visually inspect what you're doing. You can see the relative range of values here. Thankfully, none are below 0, which indicates that none of them are just like in the ocean.